Hi, this is going to be a quick walkthrough on the multi-port Eagle 30, and it specifically has to do with an application that I recently encountered, and I thought I'd document the entire process, how to go about this. So the application itself is a valve. It's apparently a pipeline or something like that, and it must be rather remote because it has both a cellular modem as well as a satellite modem. So we've got two modems. These are both on two unique and distinct subnets. So this cell modem here is going to be, all intents and purposes, for our example here, it's going to be on a 10.10.11 network, a 24-bit subnet. And then this satellite radio here will be on a 10.10.12 network, also a 24-bit subnet. So these two will not be able to see each other, and they want these two devices to be able to talk to these local SCADA devices here, both a Phoenix Contact HMI as well as a SCADA Pack IO. So it's an RTU. And what they want is they want these two devices to be able to talk to either one of these, and this means that we need to tie three different subnets together. And given the fact that there are four connections, the Eagle 20 and the Eagle 30 both have four copper ports. This lends itself very well for this. Obviously shown in this image is an RSP. The RSP does offer the same capability, but with the Eagle, the added benefit that we have is it is also a firewall. So it does stateful packet inspection, packet filtering, has a whole lot more capability than just the RSP. So the device in particular that we've got is not an Eagle 20, the multi-port Eagle 20, but it's going to be the multi-port Eagle 30. So what we're going to do is we're going to go ahead and we've got the Eagle 30. It is currently factory defaulted, and just to show you what we have on the network, I've got a few devices to simulate, or a few switches to simulate the end devices. So I've got an RS-20 here. It's one of our switches to simulate the satellite modem. Just gives me a pingable device. The satellite modem is on a 10.10.11.2 network with a .1 as the default gateway. Then we've got the cellular modem here on a 10.10.12 network. Its IP address is a .2 or 12.2. It's using the default gateway as a 12.1. So these are going to be the routed interfaces that I need to set up on the Eagle. We then also have representing the local devices a 192.168.1.2 with a 1.1 gateway that I then need to configure also on the Eagle. We then also have the Eagle up here. The Eagle is defaulted. It does not have an IP address, and just for the sake of being able to configure it, I'm going to give it an IP address of 10.10.10.2. I'm currently on a 10.10.10.99 subnet, so I should be able to talk to this device. And not quite sure what's up here. Let me do a quick rescan, make sure that I did properly address it. Here's the 10.10.10.2, and let me make sure that I can also ping this device. And as you can see, I can also ping it, so I should also be able to then talk to it. The Eagle, having the HiSec OS, is going to require the Java runtime. So for this, what I'm going to actually utilize is I'm going to utilize the HighView application. The HighView application has the Java runtime embedded in it. 10.10.2. And this is going to allow me to now manage this this Eagle. So this is HighView. This has the Java runtime embedded in it. It also allows me to do the discovery with this. I prefer doing just the discovery with HiDiscovery versus the HighView's discovery. It just tends to be a little snappier, and it's just my preferred solution. So default username and password is admin and then private. It's all lowercase. And we now see here that on our ports, just doing a quick check, you'll see that I've got a variety of devices connected into it. I've got a device connected to this port. This is actually my cellular modem. This is my satellite modem. And my two SCADA devices are going to be on these two ports right here. I'm currently connected via the SFP socket utilizing a RJ45 to SFP adapter. I'm currently connected into here. Theoretically, I can be connected into any port. So to start all this, what we're going to do is we're going to go to routing, and then we're going to go to interfaces. And first off, we're going to do routing global. We're going to enable routing. The next thing that we're then going to do is we're then going to go down to configuration, and for port 3, this is where I currently have my cellular modem connected. What I'm going to do is I'm going to give this a 10.10.11.1 interface address, and this is going to be a 255.255.255.0. And I do want to enable routing for this port. Then for this port, this is my satellite modem. I'm going to have 10.10.12.1, also with a 255.255.255.0 subnet. And I'm also going to enable routing for this. And I just hit reload just to make sure that all the values took. And so this is going to be my the gateway address for the cellular modem to connect into, and this is going to be the gateway address for the satellite radio to connect into. Now these two devices, or these two ports here, are going to be the ports where I'm going to have the SCADA, the local SCADA devices connected into. And for this, what we're going to do is we're going to create a VLAN router interface, and we're going to call this. We're going to call this 192. We can call this VLAN 10, VLAN 20. Pretty much any VLAN except for VLAN 1, and in this case we're going to call it VLAN 192 because it's going to be on a 192 address. Again, it is rather relevant as to what you call it, but just for a naming convention, it's rather relevant, or rather a good identifier. And I can then call this local. I can also call it, the name can be 192, and in this case I want ports 5 and 6 to both be members and have it as untagged. I then also want to make sure that I'm going to give it a VLAN ID of 192, which is what I'd given it on the previous screen. So it's going to have a VLAN ID of 192, and it's going to have a routed interface of 192.168.1.1 with a 255.255.255.0 address. And then we're going to hit finish, and I'm going to go ahead and delete the other ports, or delete the ports in other VLANs, so that these only talk to through that 192 VLAN. So to make sure that all of this took, I'm going to do another quick reload. And what I'm also going to do is I'm also going to go to my switching VLAN and look at my configuration. You'll notice that it automatically added port 192, and if I look at both ingress and egress, I can also see that 192 has been assigned to ports 5 and 6. So the benefit is it automatically does this through this wizard in this configuration. So technically, I believe everything is done. Let me switch ports. So I now am also going to be a SCADA device. So with this, there's going to be both devices on ports 5 and 6, which are in this VLAN on a 192.168.1 network. And then you've got your cellular modem. You then also have your satellite modem here. So the last thing I need to do is I need to ensure that if I'm connected to this, let me open up a command prompt. So if I were to type in ping 192.168.1.2, which is one of the devices that I have on here, I need to be able to ensure that I can ping that device. You'll notice that it's currently not pinging. So one of the things I need to do is I need to disable my wireless card, and by disabling my wireless card, I don't have dual this way I don't have dual gateways. And the other thing that I also need to do is I also need to make sure that under properties, one 192.168.1.99, and that I then have a default gateway of 192.168.1.1, which is the interface that I created on the Eagle. So if I hit OK, OK, go ahead and close this. Let me go ahead and minimize that. And you'll see here that I can now ping the other local SCADA device that's on my machine, or that's connected to the Eagle. The next thing that I'm going to do is I am then going to open up another command prompt. And in this one, I'm going to go ahead and ping 10.10.11.2, which is the cellular modem. Do a continuous ping by adding the -T. As you can see, I can ping that device. And what I will then also do is I will then also create a third command prompt window, and I'll do ping 10.10.12.2 with a continuous ping. So this is then the cellular modem, I'm sorry, the satellite modem. So as you can see, I can ping all three devices all at the same time, effectively creating a routed network. What is interesting, and I have yet to have someone tell me exactly why this is, if I try to ping the routed interface port itself on these devices, I do end up with a few timeouts periodically. It'll ping for a while, and then it'll have a timeout, and it'll ping for a while, and then timeout, as you can see what's happening on the 12.1 network over here. So if you're looking to ping as a means of validating your connection, do ping a end device as opposed to the routed interface. The last thing I would then want to do is I would then want to make sure that I switch back into the network that the device is in. And what I'm going to do is I'm going to connect back into the initial port that I configured the Eagle on, and I am going to, once I regain control of my cursor, I'm going to go ahead and log back into the Eagle. And because all of these changes that I've currently made are all in volatile memory, means that if I were to power cycle right now, I would lose all of the settings that I've made. So one of the things that I'd want to do is I'd want to go into my load save and just do a save, ensuring that the changes that I've made are going to persistent and remain through a power cycle. So with this, I have the assurance that the configuration is going to be permanent and will survive a power cycle. Next steps would be things like double checking the power supply. If you have a redundant power supply, you shouldn't have this. If you do, it means that one of the power supplies has failed. You can obviously ignore the power supply monitoring. You can and should also address your security statuses, making sure that you change your password from the default, and so on and so forth. And once making all those changes, again, going back to load save and saving those changes. I hope this has been beneficial, and obviously if there's anything that we can do for you, feel free to reach out to your local field application engineer for any assistance. Thanks, and have a great day.